what we are trying to do is minimize or maximize something called an objective function. So usually there's going to be something like maximize a profit function, minimize a cost function, something of that nature. So in this particular instance, these are the steps we're going to follow. The first thing we need to do is identify our objective, assign names to our variables, and then write down the objective function. Once we've got our objective function written out, the next thing we need to do is construct something called a system of constraints. Once we have constructed this system, we will graph it, identify the vertices on our graph, and then take those vertices and plug them into our objective function. Then finally, we'll interpret the results. So let's go through an actual example so that we can see how these things work. In this particular case, it says that Bob and Betty make birdhouses and mailboxes in their craft shop near Gatlinburg. Each birdhouse requires 3 hours of work from Bob and 1 hour from Betty. Each mailbox requires 4 hours of work from Bob and 2 hours of work from Betty. Bob cannot work more than 48 hours per week, and Betty cannot work more than 20 hours per week. If each birdhouse sells for $12 and each mailbox sells for $20, then how many of each should they make to maximize their revenue? So we've read our problem once. We know it's all about doing something with making birdhouses and mailboxes. Now let's pull it apart piece by piece. The first stage is that we need to identify the objective, assign variable names, and write the objective function. So let's go back to our paragraph. In order to identify your objective, there are 2 words you should be looking for, the word minimize or the word maximize. Whatever thing you're trying to min or max, that's your objective. Now, 9 times out of 10 in these problems, that objective is going to be found in the last sentence. So when you start your second read through and you're pulling apart the paragraph, start at the end and then work your way back to the beginning. So to identify my objective, I'm going to read the last sentence and I'm going to look for minimize or maximize. It says each birdhouse sells for $12 and each mailbox sells for $20. How many of each should they make to maximize their revenue? So there's my objective right there. I want to maximize Bob and Betty's revenue. Next, I need to assign variable names. That means that I need to figure out what my unknowns actually are. So again, I'm going to go back to that last sentence. It says if each birdhouse sells for $12 and each mailbox sells for $20, how many of each should they make? So that means I need to keep track of the number of birdhouses and the number of mailboxes. Since it doesn't matter what I name my variables, I'm going to let B be the number of birdhouses and M be the number of mailboxes so that it's easy to keep track. Now that I've assigned my variable names, the last part of step 1 is to write down the objective function. So remember, B and M are going to be my variables, and I need to figure out how much revenue I'm going to make from those birdhouses and mailboxes. So I go back to my sentence. It says each birdhouse is going to sell for $12. So if I take B and multiply it by 12, that's the total money I make from the birdhouses. It also says that each mailbox sells for $20. So if I take M and multiply that by 20, that's how much money we get from selling the mailboxes. Add those 2 things together and I've got my total revenue. So R equals 12 times B plus 20 times M. And now I have written my objective function. And we're all done with step 1. Step 2 is to construct a system of constraints. So we need to talk about what a constraint is. A constraint is something that puts a limitation on your scenario. We represent constraints using linear inequalities. So what I'm going to be looking for is anything that limits the number of birdhouses and the number of mailboxes that we can make. So there are 2 different kinds of constraints you're going to run into in these problems. There are natural constraints, constraints that pop up because we're working in the real world, and these ones don't get mentioned in the paragraph. We just have to know what they are. And then there are the constraints actually given in the paragraph. So let's talk about the natural constraints first. We're constructing birdhouses and mailboxes, and in the real world there's a lower limit on how many of each of those we can make. We cannot make a negative number of birdhouses, and we cannot make a negative number of mailboxes. So B has to be bigger than or equal to 0, and M has to be bigger than or equal to 0. That's what we call our natural constraints. Now, there are other constraints in this scenario that we need to pull from the paragraph. So this is where we go back to the beginning and start looking at the limitations that we have. So it says that each of the birdhouses requires 3 hours of work from Bob and 1 hour of work from Betty. Each mailbox requires 4 hours of work from Bob and 2 hours of work from Betty. It says that Bob cannot work more than 48 hours per week, and Betty cannot work more than 20 hours per week. There is the ticket for the rest of the constraints. There's a limited number of hours that each of our people is allowed to work, and there's a certain number of hours it takes for each of them to work on the mailboxes and the birdhouses. So let's see how this works out. Let's start with Bob. Bob can't work more than 48 hours a week. So all of his time working on the birdhouses and working on the mailboxes has to be less than or equal to 48. It says for birdhouses, he works 3 hours on each of them. So 3B is Bob's time on the birdhouses. And for mailboxes, Bob works 4 hours on each of them. So 4M is his time spent on mailboxes. So 3B plus 4M has to be less than or equal to 48. So that's our next constraint. Now we look at Betty. Betty can't work more than 20 hours per week. It says that Betty spends 1 hour on each birdhouse, so that's B, and she spends 2 hours on each mailbox, so that's 2M. So B plus 2M must be less than or equal to 20, or the total number of hours per week that Betty can work. So now we've built our system of constraints. Our next goal is to graph our system of constraints. So first we have these natural constraints. B is greater than or equal to 0 and M is greater than or equal to 0. At this point I need to make a choice. Which of these things is going to sit on the horizontal and which is going to sit on the vertical axis? I've decided in my example that I'm going to let the birdhouses be on the vertical axis. So there's B, and the mailboxes get to be horizontal. So there is M. Now, that means that B is greater than or equal to 0 and M is greater than or equal to 0 is stuff in quadrant number 1. So that means that when I'm drawing the system, because of the natural constraints, I don't draw anything outside of the first quadrant. Since I've decided to let B be on the vertical axis, I'm going to solve each of my other constraint formulas for B. So rearranging 3B plus 4M is less than or equal to 48 gives me B is less than or equal to negative 4/3 M plus 16. And rearranging B plus 2M is less than or equal to 20 gives me B is less than or equal to negative 2M plus 20. So I've graphed each of those lines. So the purple one right here is the B is less than or equal to minus 4/3 M plus 16. And the red one is B is less than or equal to negative 2M plus 20. And then I look to see where I shade. These say shade inside of quad 1, and both of these say shade below the lines. So underneath both of these lines in quadrant 1 is this yellow region, which I've colored in. So now we've got the constraints all graphed. Now that the constraints are graphed, I need to go around and identify the vertices. Remember that vertices are intersection points between the lines in our system that sit on the edge of our shaded region. So taking a look here, I see that my two axes intersect at the origin, so 0, 0 is a vertex. My purple line and my vertical line intersect at 0, 16. That's going to be a vertex. The red and purple lines intersect at 6, 8. And the horizontal axis and the red line intersect at 10, 0. So I have a collection of 4 vertices in my picture. Notice that there are 2 intersection points that don't count, 0, 20 and 12, 0. They don't count because they do not sit on the edge of the shaded region. So now that I've gone through and I've identified what my vertices are, I need to evaluate my objective function at each vertex. So my objective function was r equals 12b plus 20m. Now remember that I had m comma b for each one of my ordered pairs. So this first number is always going to be m, and the second number over here is going to be b. So if I plug 0, 0 into my revenue function, I get back $0. That ought to make sense. I don't make any birdhouses, I don't make any mailboxes, I don't make any money. If I plug in 0, 16, I'm making 16 birdhouses and 0 mailboxes, which gives me a grand total of $192. If I plug in 6, 8, that's 8 birdhouses and 6 mailboxes. That gives me a total of $216. And my final vertex, 10, 0, is 0 birdhouses and 10 mailboxes, which gets me $200 worth of revenue. Now we're ready to finish the problem. The beauty of linear programming is that the minimum or maximum value of your objective function has to occur at least one of the vertexes. So since I'm trying to maximize my revenue, all I have to do is look through my list of values that I just constructed and find the biggest one, the maximum value. So if 0, 192, 216, and 200, 216 is the largest. That means the most amount of money that Bob and Betty can make is $216, given their constraints on how much work they can do, which limits the number of birdhouses and mailboxes that they can construct. Now, I have to actually answer the question that is asked. Sometimes these things ask for the maximum or minimum value of the objective, and sometimes they ask you for something different. So always go back and reread the sentence to make sure you know which question you're really answering. It says, if each birdhouse sells for $12 and each mailbox sells for $20, how many of each should they make to maximize their revenue? So the answer here isn't the $216. The answer is the number of birdhouses and the number of mailboxes that Bob and Betty should construct. Since I've identified that $216 is the maximum revenue, all I have to do is look back and say, oh, that was 12 times the number of birdhouses plus 20 times the number of mailboxes. So Bob and Betty should make 8 birdhouses and 6 mailboxes to maximize their revenue. And that sentence is my final result for the problem.